The construction of a biogas plant, which is to deliver above average output for many years, requires a great deal of know-how, experience and the use of high-quality materials. This is what we at BioConstruct call intelligent biogas technology. In this film we'll show the various construction phases of a 500 kilowatt biogas plant. The shells of the fermenter and storage tanks are usually made of site-mixed concrete. This method provides high flexibility as far as the sizes of the tanks and lead troughs are concerned, and a robust design which will ensure safe operation of the plant for a good many years. This biogas plant consumes about 10,000 tons of energy crops a year, requiring two 2,200 cubic meter fermenters and one 5,800 cubic meter storage tank. After the tank has been cast and tested for leaks, we start the surface processing, the installation of the mixing device and the preparation of the roof structure. The top 2 meters of the inner surface are coated with a special epoxy resin to provide permanent protection against sulfuric acid. Roofs are fitted to the tanks under which the gas will later be stored. Our gas accumulator roofs consist of a storage membrane and a second additional weather protection foil, which is kept stable using a blower. Even under extreme weather conditions such as squalls, or with fluctuating gas production. This provides an extremely large storage volume and ensures that valuable gas is not lost during maintenance work. It is important to insulate the fermenters properly in order to maintain a stable process temperature of about 40 degrees Celsius. The better insulated the tank is, the more heat can be used effectively for other purposes later. After only about 40 days of construction, the shell of the tank has been completed and some fitting out has already been done. On top of the 2 fermenters, you can see the gas accumulator roofs ready for operation. The roofs are now covered with profiled metal sheeting to protect the insulation against the weather and to give a good overall appearance. The production of biogas requires heat. If desired, the heating pipes can be made of stainless steel, which provides the best resistance against the extreme chemical and physical impact inside the fermenters. Continuous mixing of the digestate is crucial in order to obtain a high energy yield. The mixing inhibits stratification, allowing gas bubbles to ascend with ease. Here we combine a slow rotation paddle mixer with 4-meter wingspan with a fast rotation submersible mixing device. We thus achieve optimal mixing with relatively low power consumption. Logical positioning of the machine room also ensures that the biogas plant itself will consume little energy. Gas, heating, electrical and feedstock installations are situated next to each other, keeping pumping and pipe routes short. This reduces costs and maintenance. Instead of using a massive brick building, we are able to erect a compact steel machine room. All our plants are tailor-made to suit the available space, and our civil engineers are always on site to oversee the entire construction. To optimize the efficiency of a biogas plant, it's not only important what kind of input is fermented, but also how it is transported into the plant. Again, we minimize energy demand through optimum positioning of the feed equipment. For example, we use a deep-set mixing pump so that we can use gravity instead of having to pump upwards. Because this bioplant mainly processes easily transportable maize silage, we decided to use a concrete input container equipped with a floor discharger. The concrete floor discharger is covered with protective, acid-resistant polyethylene panels on the inside. The stainless steel screw conveyors transport the material into a proportioning pump, where the input materials are mixed with the digestate and then transported onto the fermenter. We can also provide services over and above the construction of the actual plant. Our expertise encompasses grid connection, biomethane supply, microgas distribution systems, optimal energy recovery and heating networks. Here you can see the laying of a local heating system. The subsurface feedstock pipes used in this biogas plant are jacketed pipes with leakage control and meet the highest safety standards. In our industrial-sized plants, where feedstock pipelines run underground, we use fused polyethylene pipes, which are significantly more robust than glued PVC pipes. We use generously proportioned stainless steel overground pipelines for such plants. These are wide enough to supply even a 750 kilowatt unit, enabling an economical upgrade at a later date. In this biogas plant, BioConstruct is installing a prefabricated gas washing and drying module. Impurities such as dust and silicates are removed from the biogas in a scrubbing column, and cooling eliminates virtually all the water vapor. This complex cleaning process increases the service life of the CHP unit used to generate electricity and heat from the biogas. We only obtain CHP units from experienced partners who can guarantee a long life for what is the most expensive single component. BioConstruct prefers to install the CHP unit in a concrete building, as this has a longer service life and produces lower emissions than a steel container. Its generous dimensions also simplifies installation and maintenance work. As soon as the plant has been completed and all components installed and tested, initial operation can begin. Our trained staff provides competent assistance at every step. The last few adjustments are made. And then we talk the owner through every single aspect of how the system works, so that he will be able to operate his biogas plant for maximum efficiency. Here in the machine room, the owner and the BioConstruct site manager check that the mixing pump is working properly. The central stainless steel feedstock distributor can pump feedstock from any tank into any other tank. By using one single pump in the entire plant, we reduce the costs for maintenance and spare parts storage to a minimum. Now the moment has come. The fermenters are filled with liquid manure and then heated using a mobile heating system. Biogas production begins. Until the methane content is sufficient to generate electricity, any gas produced is burnt off using the BioConstruct gas torch, carbon-free. All data is centrally collected and analyzed using PLC control, and all the important plant components are also automatically controlled. Now the maize silage is fed into the production process. The buffer volume of the floor discharger means the plant only has to be filled once a day. Very soon the CHP unit can start production. generating enough heat and electricity for around 1,000 households. The biogas plant is soon running at full load, reliably, constantly, and very profitably. This is intelligent biogas technology from BioConstruct.